Now, in order to do this in practice, to do this in Python, it'll be very similar steps to what we've seen so far. We will start by importing our class, here called agglomerative clustering. We're then going to create an instance of the class. So we set ag equal to agglomerative clustering with our different hyperparameters. We can choose the number of clusters here. We set the number of clusters equal to 3 so that it'll keep building up until we get to 3 clusters. We then have the option to choose our distance metric, and here you see we chose Euclidean. Affinity equals the Euclidean. We use the Euclidean distance. And we can also define what our linkage will be. Going through the different linkages that we just discussed are available, we can choose which one we'd like to use for our current clustering algorithm. And then, as before, we would fit the instance on the data and use that to predict clusters for new data. Now let's recap what we went over here in this section. In this section, we introduced the hierarchical agglomerative clustering method and how we can use it to slowly build up to larger and larger clusters. And this method becomes very useful in business practices when you may want to also see the subgroups that build up to these larger groupings. We then discussed stopping conditions and how you may either have a predetermined amount of groups in mind or a predetermined amount of clusters in mind, or you can say to continue up until you reach a threshold of minimum average of our cluster distances. And finally, we went over different linkage types, including single linkage, using the closest points to determine distance between clusters, complete linkage, using the furthest points to determine the distance between clusters, average linkage, and ward linkage, which finds the combined clusters that most reduce the amount of inertia. That closes this video on hierarchical agglomerative clustering, and in the next video we're going to dive into our next clustering algorithm, dbScan. Alright, I'll see you there.